Many applied problems can be modeled by quadratic functions and involve finding the maximum or minimum of the function. For instance, an object flying through the air, called a projectile motion, follows the path of a parabola. Projectile motion is just one example of something that can be modeled by quadratic functions. Example 5, we're going to do a projectile motion problem. Example 5 says the height of a punted football, f of x in feet, can be modeled by f of x equals negative 0.01 x squared plus 1.18x plus 2, where x is the ball's horizontal distance in feet from the kicker. A asks, what is the maximum height of the punt, and how far from the kicker does it occur? So if you're dealing with a quadratic function and you're talking about the maximum, we're always talking about the vertex. So we want to use the vertex formula and find the vertex for this quadratic function. So x equals, opposite of b, negative 1.18 over 2 times a, negative 0.01. So negative 1.18 over negative 0.02. Okay, and if you put this in your calculator, you get 59. So x is 59 feet. Y value, negative 0.01 times 59 squared plus 1.18 times 59 plus 2. Again, if you put this in your calculator, we will get 36.81. Okay, so make sure you answer the question correctly. The question is, what's the maximum height and how far from the kicker? In our problem, it says x is the horizontal distance from the kicker, and f of x, or y, is the height. So the maximum height is 36.81 feet, and that is 59 feet from the kicker. Question B, if the nearest defensive player is 6 feet from the kicker, how high must he reach to block the punt? So in question B, 6 is a distance from the kicker. That's an x value. And we're asked how high. F of x is height, so we're being asked to find f of x. So in question B, all we have to do is put 6 into our function, get the height of the ball, and that will tell us how high the kicker has to jump in order to block this kick. So if you put in 6 into your function and type this into your calculator, you get 8.72 feet. So a defensive player 6 feet away would have to jump 8.72 feet high in order to block the kick. Question C, if the ball is not blocked and no one catches it, how far down the field will the ball hit the ground? So if we visualize this one, the ball gets kicked, goes down, and hits the ground. Okay, well that looks just like a parabola, and hitting the ground right here, we can think of that in math terms as the x-intercept. So to solve this question, we need to find the x-intercept. And we do that by letting f of x equal 0, and then solving for x. And with decimals involved, we would certainly want to use the quadratic formula. So x equals negative 1.18 plus and minus the square root of 1.18 squared minus 4 times negative 0.01 times 2 all over 2 times negative 0.01. So underneath the square root, If you type this into your calculator, we have 1.4724 all over negative 0.02. Okay, typically on a problem like this, we're asked to round our answer, so at this point we'll go ahead and finish on our calculator, 1 for the plus, 1 for the minus. So we'll have, in order to get the order of operations correct, you need to use parentheses. Negative 1.18 plus the square root of 1.4724 divided by negative 0.02. And negative 1.18 minus the square root of 1.4724 divided by negative 0.02. And again, make sure you're using your parentheses around your numerator. Otherwise, your calculator will not get the order of operations correct, and you'll get the problem wrong, even though you've done all the work up to here correctly so far. So be very careful with that. Okay, so the first one, we get negative 1.67. And for the second one, we get 119.67. So the first one is indicating going backwards. That's not what happened. And the second one, 119.67, is correct. So 119.67 feet downfield is where the ball will hit the ground. Example number 6, among all pairs of numbers whose difference is 10, find a pair whose product is as small as possible. Also, what is the minimum product? So we're looking for two numbers. Let's call these numbers x and y. The first sentence says, among all pairs of numbers whose difference is 10, meaning if I subtract my two numbers, I get 10. Okay, we want to find a pair whose product is as small as possible. So we want our product, which equals x times y, we want p to be as small as possible. So to solve this question, we want to think of our product equations, the one we want to work with, because that's the thing we're trying to make as small as possible. And on the right-hand side, it has two variables, x and y. So what we want to do here is make a substitution. Take our first equation and solve for either x or y. We can solve this fairly simply for x just by adding y to both sides and have y plus 10. So x equals y plus 10. If I substitute that into my product equation, which is the one I'm trying to work with because it says make the product as small as possible, x equals y plus 10, so replace x with y plus 10, and then we still have this y. Okay, if we multiply, we get y squared plus 10y. Okay, so that is basically a quadratic function with the variable y, and if we're asked to find a minimum, okay, that would mean that we need to find the vertex. So vertex formula normally is x equals, but since our variable is y, we'll use y equals opposite of b, negative 10 over 2 times a, no number, so it must be a 1. And we get negative 5. So y equals negative 5. How I get my other number is I go back up here, x equals y plus 10. So if I put negative 5 into that, x equals negative 5 plus 10. Negative 5 plus 10 is negative 5. Or sorry, positive 5. Okay, and so there's my two numbers. X equals 5 and negative 5 are my two numbers whose difference is 10, and product will be the smallest. Okay, our last question is, what is the minimum product? Okay, if I go back up to my product equation, product equals x times y. So 5 times negative 5, and that will give us negative 25. Our last example, example 7. You have 100 yards of fencing to enclose a rectangular area adjacent to a house. Find the length and width that maximize the area. What is the maximum area? So really 3 questions. What's the length, what's the width, and what's the maximum area? So let's draw this out first. So we've got a house. Okay, here's my lovely artwork. Okay, so there's our house, and it says adjacent to this, we're going to enclose a rectangular area. Okay, and so notice in red, we've got our fencing that we need to use, and we don't need to put a piece of fence along the house. The house acts as that barrier. Okay, so if we label how we would normally label a rectangle, this would be the length, this would be the width, and this would be the width. So the pieces of information I have in this problem is that we're using 100 yards of fencing. So 100 has to equal this picture, which has an L and 2 W's. And the other thing is we want to maximize an area, and any rectangle, area is length times width. So area is the equation we want to work with, but it's got 2 variables on the right. So like our last problem, we want to take this relationship, solve it for either length or width, and substitute into our equation for area. This one is easily solved for length by subtracting 2w. And now we can substitute into our area equation. Area equals 100 minus 2w, so that's length, and then times width. If we multiply, we have 100w minus 2w squared, and in descending order, this would be negative 2w squared plus 100w. So again, like our last example, this is a quadratic function with the variable w. And if I want to find the maximum, that involves finding the vertex. So our variable is w, not x, so w equals, opposite of b is negative 100 over 2 times a. So negative 100 over negative 4, and that's positive 25. So the width is 25. To get the length, go back to our length relationship of 100 minus 2w. So 100 minus 2 times 25. 2 times 25 is 50, so 100 minus 50 is 50. So the width, 50 feet, the length, 100 feet. And the last part of our problem asks us to find the actual area. Area is found by multiplying length and width. So 50 times 25, 1,250 feet squared.